Hello guys, again welcome to our channel, and of course this is teacher Bong Fontanilla saying, "Smile is a curved line that sets everything straight." So today we are going to talk about the factor theorem. So when we speak of factor theorem, it states that if the remainder is equal to 0, when p of x is divided by x minus c, then x minus c is a factor of the given p of x. So before we continue, please don't forget to like and share, subscribe to our channel, paki-click lang yung notification button natin for automatic updates of new videos or new posts. Thank you! Okay, let's start. When we speak of factor theorem states that if the remainder is equal to 0, then x minus c is a factor of the given p of x. So here, let us try to consider this one. It says, or we are going to show that x plus 1 is a factor of the given p of x. So this is our p of x, and this is our x minus c. Since the factor theorem states that when the remainder is equal to 0, then x minus c is a factor of p of x. Therefore, we are going to make use of the remainder theorem to show or to check it out, to find it out whether this x minus c or x plus 1 is a factor of the given p of x, 2x cubed plus 5x squared minus 3. So if we may recall, remainder is equal to p of c. And from x minus c, we are given x plus 1. Our c here is equal to negative 1. So this negative 1 will be substituted to all our x in our p of x. So we have 2 times negative 1 raised to 3 plus 5 times negative 1 raised to 2. Then we have minus 3. Simplifying it further, negative 1 raised to 3, negative 1 times negative 1, that's positive 1, times negative 1, that gives you negative 1, times 2, so we have negative 2. Negative 1 square, 1, 1 times 5, so that is simply positive 5, then minus 3. Applying all the operations, negative 2 plus 5, that's positive 3, or 3 minus 3, that gives us 0. So the remainder is equal to 0. Since we showed that the remainder is equal to 0, therefore, we say that x plus 1 is a factor of the given p of x. What is our p of x? That is 2x cubed plus 5x squared minus 3. So that is using the remainder theorem to show whether the given x minus c is a factor of the given p of x. Although in some other ways, we can also resort to applying the synthetic division. So, for this particular discussion, I would like to show the use or application of synthetic division to find out whether the given binomial x minus c is a factor of the given p of x. Because I would like to emphasize your synthetic division is very much useful, especially when we are to talk about finding the zeros of polynomial functions or polynomial equations. So using the synthetic division, Okay? So synthetic division, again, we are going to get your C, the value of C is negative 1. So we are going to write here. I just hope that there are other learners or most of our learners out there are already familiar with the synthetic division. If not, then please listen because you may learn about the synthetic division for this time. Okay. So using your synthetic division, we are going to simply consider our numerical coefficients in each of the term in the given p of x. So the first term is 2x cubed. So our numerical coefficient is 2. So we have 2. So this is our cubic term. The next term should be the quadratic term. Yes, so that is 5x squared. The numerical coefficient is 5. The next term should be the linear term. Yun yung may x na kanyang exponent ay 1. Wala dito. No? That means to say, ang kanyang numerical coefficient ay 0. So we have to put 0 there. Then our constant term, negative 3. Okay. Let us see if we will get the same result. So the first thing that we are going to do is bring down the first value. So bring down 2, then multiply it to our C, negative 1. So 2 times negative 1, we have negative 2. So these values here should be added. So we are going to add this. 5 plus negative 2, or that is simply 5 minus 2, we get 3. Then, 3 times negative 1, we get negative 3. Again, add 0 plus negative 3 or 0 minus 3, we have negative 3. Multiply again to our C, negative 3 times negative 1. Ilagay ang result dun, that's positive 3. And negative 3 plus 3, we get 0. This last value here is our remainder. So the remainder is equal to 0, which is the same using the remainder theorem. Therefore, x plus 1 is a factor of p of x. So that's how we go about synthetic division. Or that's how we apply synthetic division in showing whether x minus c is a factor of the given p of x aside from using the remainder theorem. Okay? So I just hope that you can follow. Let us try to consider number 2. Show that x plus 3 is a factor of the given p of x, x cubed plus x squared minus 7x minus 3. Using the remainder theorem, again, remainder is equal to p of c. So what is the value of our c? Yes, c is equal to negative 3. So substituting negative 3 in our p of x, we have negative 3 raised to 3 plus negative 3 raised to 2 minus 7 times negative 3 minus 3. Okay, let's simplify. Negative 3 raised to 3, negative 3 times negative 3, 9. 9 times negative 3, negative 27. Negative 3 square is 9. Negative 7 times negative 3, positive 21 minus 3. Carrying out the operations, negative 27 plus 9, that is negative 18. Negative 18 plus 21 is 3. 3 minus 3 is equal to 0. So remainder is equal to 0. Therefore, so this is the symbol for therefore, no? Our x plus 3 is a factor of the given p of x, which is x cubed plus x squared minus 7x minus 3, since the remainder is equal to 0. Okay, using the synthetic division, let us see. So our c is negative 3. So negative 3, let us try to, this is also a way to check whether the remainder theorem is really correct. So we have numerical coefficient of the leading term. We have 1. Then this is also 1. Our linear term, meron tayong linear term dito. Hindi kagaya doon kanina, wala. So 0 kanina dito. Pero dito meron. So that is negative 7. Then minus 3. Okay? So bring down 1. Then multiply it to our c, negative 3. 1 times negative 3, we have negative 3. Then 1 plus negative 3 or 1 minus 3 is negative 2. Then negative 2 times negative 3, that is positive 6. Negative 7 plus 6 is negative 1. Negative 1 times negative 3, we get positive 3 or simply 3. And negative 3 plus 3, we have 0. Did we get the same result? Yes. So r is equal to 0 or the remainder is equal to 0. Therefore, x plus t is a factor of x cubed plus x squared minus 7x minus 3. Okay? So again, that's how we go about the remainder theorem and the synthetic division if we are to show that x minus c is a factor of the given p of x. Examples 3 and 4 now. So we have, show whether x minus 2 is a factor of 5x cubed plus 4x squared minus 31x plus 6. Here, I would just like to make use of the synthetic division kasi parang mas madali sa atin. And one thing more, it is very advisable for us to master our synthetic division because this is very much useful when we talk about solving for the zeros of our p of x, which would be other topics in the discussion of polynomial function. Okay, using the synthetic division. Of course, from our x minus c or from x minus 2, ang c natin na dyan is 2. So take note, if it is negative there, then our c is positive. So we have 2. Considering now our numerical coefficients, so we have 5. The next is 4. The next we have negative 31. Then the constant term 6. Okay, bring down 5 again. Then multiply. 5 times 2, we have 10. Okay, then add 4 plus 10, 14. Multiply 14 times 2, 28. Negative 31 plus 28, that is negative 3. multiply negative 3 times 2, we have negative 6. And 6 minus 6, we have 0. Okay. Now, so the remainder is equal to 0. Therefore, our x minus 2 is a factor of the given p of x. What is the p of x, or the polynomial? That is 5x cubed plus 4x squared minus 3x plus 6. So if you want to check, you may apply the remainder theorem. So substitute mo. 5 raised to 3, 5 times 5 times 5. So parang mas mahirap siya. Ha? Then substitute also, 5, 2 pala. Substitute your 2 to x. We have 2 times 2 times 2, 8 times 5, 2 times 2. So parang mas mahirap, mas marami kang gagawin. So parang mas okay o shortcut yung synthetic division natin. So anyway, if you are going to apply the remainder theorem, then you may still get the same result. Okay? Proceed to number 4. For number 4, show that x minus 1 is a factor of x raised to 4 plus 3x squared plus 4x minus 1. So here, our c is 1 because negative doon. So ang c natin ay 1. Okay. Actually, kung c yung 1 na natin, napakadaling i-apply yung remainder theorem. Because we will simply operate yung numerical coefficients. What is the numerical coefficient of this? That's 1. Then we have positive 3. Then dito, positive 4. Then we have negative 1. Negative 1. So you operate mo lang yan. So that is 1 plus 3, that is 4. 4 plus 4, 8. 8 minus 1, that gives you 7. So, ang remainder na natin dyan is equal to 7. Let's check using the synthetic division. Yeah? So, our C is 1. So, numerical coefficient natin dyan is 1. Then, take note, ang leading or the degree is 4. So, 4, 3, 2, 1, 0 siya dapat. Pero yung exponent natin na 3 ay wala. So, meaning to say, 0 ang kanyang numerical coefficient. Then, we have 3 here. So, we have 3. Then, 4. Then, negative 1. Yung exponent natin dito na 4, dito ay 3, dito ay 2, dito ay 1, dito ay 0 o yung constant term. Okay, so we have 1. 1 times 1, 1. 0 plus 1, this is still 1. 1 times 1, so this is still 1. 3 plus 4, 4. 4 times 1, 4. 4 plus 4, 8. 8 times 1, 8. Negative 1 plus 8, that gives us 7. The remainder. So, parehas lang siya. Yeah. Now, so, don't forget, ang shortcut, kapag ang C natin ay 1, we will simply operate the numerical coefficients. So, we have 1 plus 3 plus 4 minus 1. That gives us 7. The remainder. So since remainder is not equal to 0, therefore our x minus 1 is not a factor of p of x. Yeah. So our x minus 1 is not a factor of x raised to 4 plus 3x squared plus 4x minus 1. So that is the factor theorem. As a summary, if we are going to discuss about factor theorem, we are going to use the idea or the concept of the remainder theorem and the synthetic division in dividing x minus or dividing p of x by x minus c. So we have two important concepts when we are going to learn about the factor theorem, the remainder theorem and synthetic division.